And it has a lot. So it's just the different types of graphing that we've learned, except now we're throwing in the inequality aspect. So we've learned how to graph standard form equations, and we've learned how to graph slope-intercept form equations, and now we're throwing in just the inequality to that. So we're going to talk about the different inequalities. So this is less than. Now, do y'all remember, does less than get a dashed line or a solid line? Anybody remember? It's actually dashed.
Oh, because the one that's with the colored hole is solid.
Okay, and this is greater than. And it is also a dashed line. And it's because they don't have the equal to aspect. Okay, these two have an equal to, so they will not be dashed lines. Now, dashed lines, bless you, do not hold solutions. Okay, this is less than or equal to. So it's going to be a solid line because of the equal to. This is greater than or equal to. And it's also going to be a solid line because it's equal to. Now, solid lines do hold solutions. Okay, if y is less or y is less than or equal to, well, if something's less, and this is only if y is alone, so this is only slope-intercept form, okay? If y is less, or if you are less than something, are you above it or below it? Below, so you're going to shade below. So less and less than or equal to are both going to be shade below. So if y is greater, or y is greater than or equal to, why did I write G? Y is greater than or equal to, what do you think you're going to do?
Shade above.
Shade above. Okay, any questions with that? Okay, so looking at the first one, it says y is less than 3x plus 1. So if y is less, is that going to be a solid line or a dashed line?
Dashed.
And what's your slope? 3, which is the same thing as 3 over 1, which means I'm going to rise 3, run 1, because they're both positive. What's my y-intercept? 1. So on my y-axis, I'm going to put a point at positive 1. Y'all be very, very careful. I saw lots of people putting them on their x-axis yesterday. Okay? And I'm going to rise 3, run 1. So rise 1, 2, 3, run 1. And I can also do opposite, opposite, and go down 3, left 1. And we said it's going to be a dashed line. A lot of times with dashed, y'all, I will just connect every other dot. So are we going to shade above or below with y is less? If something's less than you, y is alone. Y is less. If something's less than you, that's below you. Your shading does not have to be perfect. You don't get extra points if it's beautiful. Okay, as long as I know where you're shading, I'm happy. Okay, so then it says, is -1, -2 a solution?
No.
No or yes?
No.
No, why not?
Because it's not in the shaded area.
It's on what kind of line?
The
A dashed line. What if it was a solid line? Would it be a solution? Yes, but it's because it's on a dashed line, so it's not a solution. Now, I want you to realize too, you'll see why I'm doing this in a little bit. You can do it mathematically. Okay, now what if you didn't have the graph and I said, hey, is this a solution to that inequality? Okay, you would literally just plug it in. Well, this is my x, this is my y, so instead of y, I'm going to write -2 is less than 3 times x, which is -1, plus 1. Well, you don't have to do any math in your head. 3 parentheses -1 plus 1 is -2. Is -2 less than -2?
No.
No. So are we accurate? Yeah.
Oh, yeah.
Does that make sense?
No.
Why? Did it make a true statement?
Oh, yeah.
It did not make a true statement. Therefore, it is not a solution. So then 3, 1, what about 3, 1?
Yes.
Yeah, it should be a solution. So if I plug it in, it should give me a true statement. So 1 is less than 3 times x is 3 plus 1. Well, what's 3 times 3? Plus 1.
10.
Is 1 less than 10? Did it give me a true statement? Yes. So this gave me a true statement, which is what it should have given me because I said it's in the shaded area, right?
Do you have to do it that way?
Mathematically? No, you'll understand why I'm doing this when we get to the back. Okay, and then last but not least, this one we will plug in as, first off, -2, 2. Is it a solution?
Yes. Oh, no.
No. Okay, it's in a non-shaded area, so it should not be a solution. So when we plug it in, we get 2 is less than 3 times -2 plus 1. Well, that gives me -5. Is 2 less than -5?
No.
No, so this is a false point. So what I want you to notice is that the shaded side should always, it doesn't matter which point you test, it should all give you true solutions, yes? If you were to plug it into the inequality, it should be true everywhere in the shaded area, correct? But in the non-shaded area or on the dashed line, it will always be false. Yes? Okay, so you hold on to that until we get to the back. Okay, this one gives me the graph and says to find the inequality. Well, we are putting it in slope-intercept form, which is y equals mx plus b. Obviously, we're not going to use an equal sign because it's shaded. Okay, but I need to find m and b. So I know y, and is it shaded above or below?
Above.
So is that going to be greater or less?
Greater.
So I know greater. Is it going to be equal to?
No.
No, why not?
Because it's dashed.
Because it's dashed. Okay, now what's my y-intercept?
2.
2, so b is 2. And I have all my pretty points plotted, or most of them, and so I'm going to go down 2, right 1, 2, 3. Now, down is negative, but right is positive, correct? So what would that be for my slope? -2/3. So I know -2/3x plus 2. That is my slope-intercept form inequality. Any questions with that? Okay, when you're done writing that down, I want you to flip to the back. Okay, do we notice what form we're in? Whoop.
Mm-hmm.
What form is it? It's not slope-intercept anymore. Still starts with an S. Standard. So it's in standard form. How do we know it's in standard form?
Oh, because X and Y.
X and Y are on the same side. Okay, but we can still tell what line. Now, however, shading above and below is different now. And we'll talk about that in a second. Okay, you can't just look at your symbol and say above or below. Because if you were to solve for Y, if you ever multiplied or divided by a negative, wouldn't you have to flip your symbol? Mm-hmm. Yeah, and we're not solving for Y, so I'm going to show you what we're going to do. First off, solid line or dash line? Solid. Today's a really good day to use pencil. Okay, because if you forget and you did a solid line and it can erase little dashes. You know what I mean? On your practice. Okay, X-intercepts are where Y equals 0. So in my equation, or inequality, sorry, I'm going to put in Y is 0. And we know that 2 times 0 is, so this cancels. And so I would divide both sides by 3. And now we are looking for on the equation. So if you use an equal sign here, that's okay. You don't have to worry about your symbol here. So we get X equals 2. So on my x-axis, I'm going to put a point at 2. Do I have to find my y-intercept?
No.
Could I just use the slope from here?
Yeah.
You do not have to find both. However, you could catch mistakes if you find it sometimes. Like if you were doing a positive slope when you were supposed to do a negative slope, if you have both your intercepts on there, you should catch that. Does that make sense? So, I mean, it could be a positive, but you don't have to. So how do I find slope from standard form? So opposite A over exact B. I'm going to write it in words versus negative A over B because some people are getting confused with it. So what is the opposite of my A? Negative 3 over exact B. Negative 2. And 2 negatives makes A. So I'm going to rise 3, run 2. Okay, which means I can also do opposite, opposite, which is down 1, 2, 3, backwards 2. And we are doing a solid line. Now, to figure out if you're shading above or below, we use a test point. What point do you think is the easiest point to test?
Like, that's on the line already?
Not on the line. You actually want to pick a point that's not on your line because we know the line holds solutions. We're trying to figure out shading. So we need to pick somewhere that's not on the line, which is where I would shade or wouldn't shade. 0, 0. Wouldn't 0, 0 be super simple to plug in? And is 0, 0 on my graph, on my line? No, so let's test 0, 0. So I'm going to plug it into my original. So 3 times 0 minus 2 times 0 is greater than or equal to 6. Well, 3 times 0 minus 2 times 0 is just 0. Is 0 greater than or equal to 6? No, this is a false point. Well, on the front, didn't we talk about how one side's false, therefore the other side was true? So if this side's false, what should this side be? And we always shade which side? The true side. So are we shading above or below on this one? Below. And now if you would have looked at your symbol, you would have thought above. And that's why when y is not alone, you cannot use that method. Does that make sense? Okay. Now, what if 0, 0 is on your line? Can you choose that point?
No.
No. You can choose any point on the graph that's not on your line. Yes? Okay. So I want y'all to start number 4 while I take attendance really fast. We're almost done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Question? You have to find it. Oh, this one? We didn't find it because remember, you only need 1 point and 1 slope to graph. So since I found a pretty point with my X-intercept, I didn't worry about my Y-intercept. Does that make sense? Okay, again, what form is it in? Okay, solid line or dashed line?
Dash.
Okay, my X-intercept is where Y equals 0. Well, anything times 0 cancels, and I would divide both sides by 2. And remember, you can use an equal sign here because we're worried about on the line. What's negative 20 divided by 2?
Negative 10.
Did that give me a pretty point? Yeah, can I plot that point?
Yes.
Barely. Now, what if it was like negative 15 and I couldn't plot it? What do you think you should do? You would have to find your Y-intercept, right? Okay. Now, you can find your Y-intercept. So we found our Y-intercept. That's where X equals 0. So 2 times 0 minus 5Y equals negative 20. Anything times 0 is 0, so divide both sides by negative 5. And I get Y equals what? 4. So I should cross here. Now, what's my slope? Opposite of A
So negative 6.
over exact B.
Negative 5.
And 2 negatives makes
A
a positive. So rise 2, run 5. Well, if I rise 2, run 1, 2, 3, 4, 5. Rise 2, run 1, 2, 3, 4. Did it bring me back to my Y-intercept? Then I did the slope correctly. Okay, and this is a dashed line. Now, I'm going to pick a different point that's not 0, 0 this time because I'm just going to show you it's still the same thing, yes? So we're going to test the point 0, 9, which is this point right here. Okay, and when I plug that in, I have 2 times x, which is 0, minus 5 times 9, which is y, is less than negative 20. And use your calculator. 2 times 0 minus 5 times 9. I get negative 45 is less than negative 20. True or false? True. So if this side is true, what's this side? False, so we're going to shade above. Any questions with that? Okay, this last one is just kind of bringing us to what we're actually going to do. It's like foreshadowing what we're going to do tomorrow. Okay, so if you notice, it's the exact same graph as the one on the front, but it says this time to put it in standard form. So there's 2 ways to do it, but the easiest way to do it is to put it in slope-intercept form first to go backwards. So what was my slope-intercept form for number 2? Well, it was y is greater than negative 2/3 x plus 2. Now, with standard form, x and y are on the same side, but can x ever be a fraction? Do you ever have fractions in standard form? No, so how can I get rid of that 3? Yeah, it's divide 3, so I'm going to multiply 3. But what I do to one term, I have to do to all of them. So 3 times y is 3y is greater. When multiplying and dividing, we multiply the whole sides. Well, when I multiply it by this guy, doesn't it just cancel the denominator and I have negative 2x? And then 3 times 2 is 6. Now these did not have denominators to cancel, therefore I actually had to multiply them. And now how do I move x to the same side? Not divide, because it's not by itself. We're going to add it. And is that a positive 3 or a negative 3y? Remember, it's positive. Negatives are always labeled. So x should go first, and we get 2x plus 3y is greater than 6. Any questions? Okay, so you have a practice. If you notice, I was super kind on the practice. There's only 12 of them. And the first 9 are like the front and slope-intercept form where you just graph it and shade. You don't have to do anything to find out where. There's only 3 that are like the back to help you. Now, everybody look at number 8 and 9. Are these special cases? Or do they have both letters? They have both letters. Y'all, these are not horizontal or vertical lines. I've seen that a lot today. What's your y-intercept on these? 0. If it doesn't have a plus or minus, it's just 0. So both of these are going to start at the origin. What's your slope? 1. If there's no number in front of x, there's a 1, which is 1 over 1, so you're going to rise 1, run 1. So be very careful on those. I've had lots of people giving me horizontal or vertical lines.